Hello everyone, my name is Sarbajit.
And my name is Karter Chong.
Today we will be talking about our science fair project, which is about the optogenetics. Let's begin.
In recent decades, new technology has been developed and improved by each generation. In the world of medical care, one important technology that helps us understand how our brain works is the optogenetic monitor. While this technology is not perfect, it offers a way to study how neurons in our body function. However, it has some challenges, such as the need for injections, which can be uncomfortable and may interact with the neurons differently. Even with these challenges, optogenetic monitors are powerful tools. They are helping researchers improve more about the brain and nervous system. Scientists are working hard to improve these devices and make them even more useful in medical research.
Before we dive deeper into the topic of optogenetics, we first have to know the somatosensory system. The somatosensory system is an important part of how we experience the world. It's the part of our nervous system that helps us feel things like touch, pain, pressure, and temperature. The somatosensory system is divided into three parts: exteroception, which helps us to sense things outside our body, like when something touches our skin; proprioception helps us to know where our body is and how it's moving, like when we walk or ride a bike. Lastly, interoception deals with sensing what's going on inside our body, like when we feel hungry or thirsty. The somatosensory system helps us interact with the world by sending signals from our skin, muscles, and joints to our brain. For example, if we touch something hot, our skin feels the heat and sends a message to our brain, telling us to pull away. This helps protect our body from harm. Optogenetic monitors are crucial and useful when it comes to certain types of topics such as the somatosensory system. It is active enough to make sure that the specific neuron cells in our body have better activity. This is done by using the power of light, thus making it a very significant tool for our daily neuroscience investigation. The idea of optogenetics had been introduced by famous scientist Francis Crick, who was well known to be a molecular biologist. The idea of this concept traces back to 1979, where he had originally established the idea of providing the supply of light to specific neuron cells. The ideas which he had came up with at the time were quite instinct. One factor which held neurologists back is the fact that they didn't have much understanding about how such project and how exactly the method should be in order to succeed it. There is someone who had identified a method on how optogenetics can be refined from connections of the brain. That man is called Desserot, an American scientist, professor of bioengineering, and a psychiatrist. He was considered to be the father of optogenetics. He and his team had cooperated together and came across the idea of putting an optogenetic monitor without any invasiveness to track the brain activities of mice. The actions of the optogenetics are fundamental in terms of controlling the neurons due to the process of stimulating the neuron cells. This is because magnetic and electrical interventions had enhanced the behaviors of the depolarizing cells, referring to the change, which effectively evolves over time as factors of the neural activity grow at a rapid pace according to science. A downside of these interventions is that they cannot detect and identify every single type of neural cells located in the area. Instead, most of them look very identical according to the intervention. This is where optogenetics comes in. Its job is to put antennas or sensitizers in order to bring along the external sources needed for each type of neuron cell. This process is fundamental because this is how light sensitive neuron cells can be produced from those light sensitive antennas. The theme of optogenetics had shown a much easier way into these neuron methods. One aspect that appears a little off regarding the functioning of optogenetics was its multi-component. This refers to its ability towards overcoming obstacles in order to effectively target each variety of neurons.
Neither of these two techniques, electrophysiology nor imaging, serve as a complete substitute for the perfect ability to control or manipulate one neural subpopulation at a time while simultaneously observing its activity. An optogenetic monitor really does bring both together. It offers a real-time feedback loops where the experimenter can trigger and register outcomes of neural manipulation through light. Neurocircuit study. To unravel the complexities of intricate brain circuits, it is required to manipulate the activity of specific neurons with a high temporal and spatial resolution. An optogenetic probe does this by combining optogenetics, a light-based beam of manipulation with any kind of monitoring, such as imaging, EEG, or fMRI. It can really derive information about how each neuron or circuit contributes to cognitive functions, memory, locomotion, and emotional response. The development of optogenetics have significantly impacted the topic of epilepsy. In many research studies, there are plenty of animal models which provide evidence of having epilepsy. These animals were mostly rodents such as mice and rats. In these particular animal models, the optogenetics immensely focuses on regulating the amount of neuron cells which would be present and have connections to the organism's brain in order to manipulate and control the seizure activity. Diving more deeply, a study shows and demonstrates how the optogenetic monitor can also stimulate the neurons around the area of the hippocampus and that can deal with the seizure that takes place. In general, this approach towards dealing with seizures using the help of optogenetics will also help towards developing more therapeutic strategies in order to fully be able to manage epilepsy.
Although the Parkinson's disease has no cure for it, there are several treatments that are available for it. Some characteristics that the Parkinson's disease has to do with having difficulties on certain activities, such as the ones that involve balancing and coordination. Other common characteristics are shaking and having a stiffness on your body. The Parkinson's disease associates with a degeneration of the dopaminergic neurons. The Parkinson's disease also has terms such as motor symptoms, which refers to things like dizziness, slowness, weak, etc. The use of optogenetics would further selectively stimulate the dopaminergic neurons, and it functions in order to reduce the motor symptoms towards the Parkinson's disease in the animal models. Furthermore, this would provide a more advanced treatment towards neurological disorders such as Parkinson's disease. Additionally, the term associated with the Parkinson's disease is called bradykinesia. Bradykinesia is the cardinal symptom which actually refers to the slowness towards movement and having difficulty with doing things within a certain or regular motion. Just like Parkinson's disease, the role that optogenetics play in the symptom of bradykinesia is that it stimulates the D1-SPNs in resulting of reducing the impact of the symptom towards the animal models. The D1-SPNs are known as the type D1 dopamine receptor, and it is responsible for keeping the neurons continuing to develop even after hormones of dopamine being in tight with them.
When Alzheimer's disease occurs, it leads to the degeneration of neurons that are in our brain, especially in the hippocampus. This often leads to problems relating to memory loss. Here's where the part of optogenetics come in. They are used to manipulate circuits of the hippocampus in the animal models. This means that the optogenetic monitor also has the ability to rearrange and lessen the impact of neural circuit and impairments towards memory. Research studies also show that the optogenetics had been used in certain pathways of the Alzheimer's disease and had a better overall memory performance in the models. Because of its fundamental process with harnessing the power of light, the optogenetic monitor is responsible for stable control over neuron cells and offering a high level of manipulation as these cells can be controlled. This process is a fine refinement of what scientists had been experimenting with, investigating newer techniques behind these discoveries for unparalleled insights. The optogenetic monitor remains a complex mechanism for further investigations of behavioral patterns or even diseases. The idea of optogenetics. The idea of optogenetics had been changed over time as it had increased its quality of performance over time. As this device continues to evolve, the more deeply it could be sense of information based upon the nervous system. It may also stand out as an excellent method towards detecting mental health disorders such as Parkinson's disease, which describes the brain's condition of going through mental health problems. Other than detecting diseases, the advanced optogenetic monitor can guide us through therapies, which remain as a long-term solution against challenging conditions. Thus, this can bring on the betterment towards many people, and it will be life-saving for countless amounts of individuals in our world.
Furthermore, the optogenetic monitor will continue to evolve with stronger cooperations among different groups of people, including engineers, biologists, and others. These collaborations should continue to embrace the changes and make the optogenetic monitor continue to stand out in the newer generation of personalized medicine, which allows the treatment to be even more customized. With that being said, the optogenetics would also bring a more comprehensive impression towards healthcare. Therefore, we are truly fascinated by the overall topic of optogenetics, not only because of its wonderful capabilities in the present, but also because of its remarkable changes and applications, as they all apply to the activities in our world. Looking back to its history, the optogenetic was known as a method to study the neural activities. It had now become an essential technology for the future medical application, with immense promise of developments throughout the journey. Additionally, this not only drives us through a better understanding of neuroscience, but also remarks the entire path towards groundbreaking innovations and an upgraded healthcare system set for the future generations.
Thank you for watching.